All right, in this video, we're going to look at end behavior or long-term behavior of a polynomial. So the end behavior of a function refers to what's happening to the output values the farther or further rather the graph of a function heads left and also heads right. So in other words, what's happening to your y coordinates the further x goes towards infinity to the right, or the further x goes to negative infinity or to the left. So let's take a look at what the end behavior of our function here, f of x equals ax to the n, where a is a positive real number and n is an odd integer. And we'll look at Desmos here and see what happens here. So we have a as a positive real number and n is an odd integer. So a is a positive real number. So let's do f of x equals, I don't know, let's do 0.45. And then it told us that n was an odd integer. So I'll use x, or yeah, x is my variable. And then we're going to raise it to, let's say, the third power. We can even raise it to the first power. So as we go further to the right, our y values are going up. And as we go further to the left, our y values are going down. Well, let's see if we change it from 1 to another odd power like 3. Well, here we notice that as we go to the right, as your x values increase, your y values are going up. And as we go to the left, as your x values go to negative infinity, your y values go down. So it appears that the graph goes goes up as we go to the right and down as we go to the left. So as x goes to negative infinity, our function, our y values also go to negative infinity. So the further to the left we go, the further down our function goes. So we got negative 7.43. We can even go, negative 12.667. And then as we go to the right, as x gets more and more positive, goes further to the right on the x-axis, our y values go up forever and ever and ever. So as x goes to negative infinity, our y values go to negative infinity. And as x goes to positive infinity, our y values go to positive infinity. And now we're going to introduce a notation here that you'll see in future math classes called limit notation. So this first one says as x approaches negative infinity, so as we go to the left, our y values are approaching negative infinity, or our y values are going down. So the limit notation for that is the limit as x approaches negative infinity of our function is negative infinity. So we can just copy this information here and put it below this lim for limit, and we can copy this function here and this value that it goes to and put it right here. So just replacing this arrow with an equal sign. Likewise, as x goes to the right, or as x approaches positive infinity, we can just put that below that limit notation. Our y values, or our function values, are also approaching positive infinity. So y values, limit as x approaches infinity of f of x is infinity. So just want to get you used to seeing this notation because you will see it later in future math courses. All right, let's take a look at the end behavior now where a is a negative real number and n is an odd integer. So we're going to make this, let me go back home here. Now let's make this a negative number. And if you recall from transforming functions, that reflects the graph over the x-axis. So now as we go to the left, as x approaches negative infinity, now our y values are going up to positive infinity. And as x approaches infinity, or as x goes to the right, our y values are approaching negative infinity. They're going down forever. So what happened was we reflected our graph across the x-axis, and now instead of going down as we go to the left, now we're going up. And instead of going up as we went to the right, we're going down. So we'd say that the limit as x approaches negative infinity of our function is infinity. So our y values are going up forever without stopping. And as x approaches infinity, or as x goes to the right, our y values are going down forever, approaching negative infinity without stopping. So again, that just is a reflection across the x-axis. Now let's look at where a is positive again, but now let's look at where n is an even integer. So we'll make this positive, and now let's make this an even integer, like 2. So here as we go to the left, we're going up forever, and as we go to the right, we're going up forever. Let's make this a 4. It's still, as we go to the left, we're going up forever. And as we go to the right, we're also going up forever. So this time, as x goes to the left, or as x approaches negative infinity, our y values are going up forever. So f of x is approaching positive infinity. And as we go to the right, or as x approaches infinity, our y values are also going up forever, or our y values are also approaching infinity. So here we have the limit as x approaches negative infinity of our function is infinity. So it goes up forever without stopping. And as x approaches infinity, or as x goes to the right, our y values of our function also going up forever or approaching infinity. All right, finally, let's make a negative. Again, you probably have an idea what's happening here, so we're just going to flip it over the x-axis, and now as we go to the left, we're going down forever. As we go to the right, we're also going down our graph forever. So now, as we go left and right, our y values are going down to the left and down to the right. So we say the limit as x approaches negative infinity of our function is negative infinity, and the limit as x approaches positive infinity of our function is also negative infinity. Or in other words, as we go further to the left, our graph is going down. As we go further to the right, our graph is going down. All right, so that about does it for this video. We'll look at some examples in the next one.